ASAP has visualization tools for two-dimensional or three-dimensional analysis, Cartesian plots, polar plots, bird's eye views. You can do 360-degree polar plots, as well as many other forms of analysis. Let's take a look at an illumination system and some of the output that we can visualize. In this particular case, we're going to create a street lamp and then visualize the geometry as well as perform some analysis. The lamp is made up of several parts, which are each imported from separate CAD files, and each CAD file has the appropriate physical properties in terms of index of refraction and possibly surface scatter applied to it. We have a bulb within the geometry of the street lamp, and then we'll watch the rays as they leave the device. And then we can perform analysis either at the street level or offset to ensure that we have a zero cutoff fixture or meet any other requirements for our particular design. Okay, so here's the results of looking at the geometry and the ray trace. Now let's take a look at some of the analysis. Okay, some of the analysis we can look at not only is looking at the geometry and a visualization of the ray trace, but we can also look at lit appearance type data. And with the lit appearance information, we can look at it in a linear scale, or if it's going to be light visualized by the human eye, we might want to look using a logarithmic scale that more represents the ability of the human eye, so maybe a log scale of 2.3 to 2.5. We can also look at adding multiple street lamps and get an idea of what the overlap of the coverage is for the street lamps. And again, we can look down at the ground level, or we can also move our detectors to any other location to get an idea of what the distribution of energy is off the street surface. And here's the effect in a logarithmic scale of using 4 street lamps. And as we can see, we have a lot of light near the lamps themselves and some spread out from the lamps, but we do have a dark region that we might want to adjust so that we have a more uniform spread. We can also look at contour plots, and we can look at these in terms of whichever type of energy unit we need, lux, foot candles, or even watts. Normally for a photometric we would use foot candles or lux. What we're seeing here are our contour plots. The black triangle indicates the point of maximum intensity, and we can look at this in flux per square inch, so we're looking at the energy across an area. We can also look at it in terms of an intensity versus angle plot. We can do plots in direction cosine space. And this is again the same contour type plot, but in this particular case we've added the 4 street lamps. And this is that dark zone between the lamps. Within the ASAP display command, you'll see that there are many types of graphical analysis available to you that can be performed on any of these ASAP simulations. So within ASAP, you're not limited to the graphical representation of your data or simply a large text file of information. You can look at your data in whatever way is most appropriate for your particular application.